Hello everyone. I wanted to make a quick video for you to go through a couple last examples with parallel parking with our inverse trig functions. By parallel parking, I mean these composed functions where you have functions within functions, and one of them is going to be a forward trig function, one of them is going to be a backward trig function. So you got to go forward and backward in the same problem. It's a hard thing to make your brain do. So we're going to practice a couple. So let's start with number 11 here. If we need to do the tangent of the arc cosine of negative 8 over 11. Okay, we're going to start on the inside and work our way out. That's how we do these. So if I start on the inside, I'm going to do the arc cosine of negative 8 over 11. Okay, this is a backward trig function, which means this is my ratio. It's inside cosine, so it's adjacent over a hypotenuse. And I have the ratio. I need to work backwards back to the angle that it came from. Because my ratio is negative, I know that the angle this is going to take me to is going to live in quadrant 2, because that's where arc cosine goes with a negative ratio in it. Okay, so when I do the inverse cosine of negative 8 over 11, I'm going to get an angle that lives in quadrant 2 that has a cosine value of negative 8 over 11. Okay, negative 8 over 11, that ratio does not live on the unit circle or our special triangles. So if it doesn't live on the unit circle, we're going to have to draw a triangle. And again, we're drawing our triangle in quadrant 2 because arc cosine will return us an angle in quadrant 2. So I'm going to draw my triangle in quadrant 2. And so when I do the inverse cosine of negative 8 over 11, this is going to give me some angle. I don't know what it is because it's not on the unit circle, but it's going to be an angle right here in quadrant 2 that has a cosine value of negative 8 over 11. That's adjacent over hypotenuse. So I know the adjacent side in this triangle is negative 8. My hypotenuse is 11. And this makes sense because this x side is along the negative x-axis. That makes sense that it's negative. Okay, so this angle right here, that's theta. That's what's going to come out of inverse cosine of negative 8 over 11. I don't know what angle that is, but that's okay. That's not the answer to this question. After I get that angle out, I still have a tangent out here, so I need to take the tangent of that angle theta. That's going to be the answer to this problem. So in order to do that, we need to find our opposite side over here. So we're going to do the Pythagorean theorem. So I'm going to do negative 8 squared plus y squared equals 11 squared. So 64 plus y squared equals 121. So you're going to subtract 64 from both sides, and when you do that, you're going to get y squared equals 57. And that means that y is going to be plus or minus the square root of 57. So we're going to look at our triangle. Is this y value positive or negative here? In quadrant 2, that's positive. So this side is going to be positive square root of 57. And so now we can finish this problem. The tangent of that angle theta, that's going to be opposite over adjacent, which is the square root of 57 over negative 8. That is going to be the answer that comes out of this thing at the end. So that's how you want to do these. If it doesn't live on the unit circle, just draw a triangle. Make sure you put it in the correct quadrant and that you're careful with your negatives. Okay, let's work number 12. What if we have the cotangent of the arcsine of 4v? And it's saying assume v is greater than or equal to 0. Really what that's telling us is that 4 times v in here, that's going to be a positive number. and we'll use that in just a minute. Okay, so we're going to start where we always do, on the inside, and we're going to work our way out. All right, so we need to find the arcsine of 4v. This is a backward trig function, so 4v is my ratio. That is my opposite over hypotenuse ratio from sine, and I need to work my way back to the angle that it came from. Now, because v is greater than or equal to 0, I know that my ratio is positive, which means this angle that comes out of arcsine of 4v, that angle is going to live in quadrant 1. Is it going to live on the unit circle? Absolutely not. There is no 4v on the unit circle or our special triangles, so we need to draw a triangle. So again, I'm going to draw my triangle in quadrant 1 here. So I will draw my triangle in quadrant 1. And what's going to come out of inverse sine of 4v is some angle. I don't know what it is. I'll call it theta. It's this angle right here. It's that angle in quadrant 1 that has a sine value opposite over hypotenuse of 4v, and I'm going to write that as 4v over 1. That's opposite over hypotenuse. So I know in my triangle here in the first quadrant, my opposite is 4v, my hypotenuse is 1. Okay, now, I have no idea how big this angle in quadrant 1 is in this triangle. That's okay. I don't actually need to know how big it is because theta is not the answer to this problem. I still have a cotangent out here on the end. So the answer that I'm looking for out of this whole problem is the cotangent of that angle theta, adjacent over opposite. Okay, so I just need to figure out what this adjacent side is. So I'm going to do the Pythagorean theorem in this triangle. So I'm going to have x squared plus 4v squared equals 1 squared. That's just the Pythagorean theorem. And just to make sure I'm clear with what I'm solving for, this x is what I'm solving for. This v over here is just a variable, and we're going to have these in our answer, but x is the side here. That's what I'm really solving for. Okay, so to do this, we still have x here, and then switch back to here. So we have x squared plus 4v, that quantity squared turns into 16v squared, and 1 squared is 1. Now I'm still trying to get x by itself here, so I'm going to subtract 16v squared from both sides. And so I'm going to have, again, I'm just going to keep this red so I know what I'm solving for. And so I'm going to have x squared equals 1 minus 16v squared. To get the x by itself, I'm going to take the square root of both sides, and I have x by itself. And x is plus or minus the square root of 1 minus 16v squared. So is this going to, this x, is that going to be plus or minus here? Well, this is in quadrant 1. X is positive in quadrant 1, so it's going to be the positive square root of 1 minus 16v squared. And this square root will not simplify. This is not going to be the square root of 1 minus the square root of 16b squared. You can't distribute a radical or a square root over subtraction. Addition and subtraction ruin everything in algebra. So you can't do that. You got to leave it as the square root of 1 minus 16v squared. Okay, so now what do we do? We've got our triangle. Oh yeah, I remember. We're trying to find the cotangent of theta. So the cotangent of theta, when I take the cotangent of this angle down here, I'm going to get the ratio of adjacent over opposite. So that's going to be my adjacent side is the square root of 1 minus 16v squared all over my opposite side, which is 4v. This is going to be what comes out of this composition function. And because our original had a V in it, our answers will have V's in it too. You'll just set up your triangle in the correct quadrant, work it just like normal, and then make sure that you take the correct ratio at the end. All right, I hope this was helpful. I hope you have a great spring break, and I will see you on Monday, March 13th in class.